Today in section 2.7 we will learn about quantifiers. The objectives are to translate statements with quantifiers to English and vice versa, and to determine whether a statement with quantifiers is true or false. So what are the quantifiers and why are they useful? What do they do that we couldn't do until now? So there are two of them. One of them is called the universal quantifier, and one of them is called the existential quantifier. The universal quantifier is written with a turned A, and it stands for all or for every. The existential quantifier is a turned E, and it stands for there exists or there is a something. I imagine these two letters turned come from the fact that a century ago they needed new symbols, and the best, easiest way to do it was just to use an A and an E and put them upside down. So, here are a few examples. So, we'll read these sentences and translate them to English, and we then will give an example of such an object which exemplifies what the statement says. So in A, we have for all. So for all n in n, once you read that, you can say it's for every natural number n. 2n is even. So here's how it would look like in English. For every natural number n, 2n is even. Now let's pick an example. If we choose n equals 7, then 2n is 14, and 14 is even. So it's a true statement. B. So when we read this, there exists x, except for the fact that x is a capital letter, which hints at the fact that it might be a set, we don't really know what x is. So even when you read what I wrote here, there exists a set x. This is usually not what happens the first time you read a sentence. Usually you're going to read that and you're going to be, there exists x such that x is included in the power set of n, and the cardinality of x is 5. When you rephrase it, you will write something maybe better in terms of English. There exists a set x which is a subset of n and whose cardinality is 5. Example, one of many. For example, x is the set consisting of the first 5 even numbers. So now we'll do the same thing but the other way around. Write these English sentences using symbolic statements. There is an integer such that its square is 7. So there exists a number n in Z such that n squared equals 7. And that happens to be a false statement, by the way. B. Given any two rational numbers, their product is rational. So for all x and y in Q, xy is in Q. And that's a true statement. So, note that if we have a property, p of x or something else, then we can also use it in our symbolic statements. For example, if we define e of x to be the property that a number x is even, then we can write there exists a natural number n such that n is even. Right, we used this property here. It means n is even. So instead of spelling it out like we did a couple of lines above, we can use this property. Now here we have a final exercise which really draws our attention to the fact that the order in which we write statements is very important. determine whether the statement is true or false. And note that the only difference between A and B is that there's a difference in the order in which the quantifiers are written. Here it's for all x in R, there exists y in R such that something, and here it's there exists y in R such that for all x in R, something. So let's read the first one again. For any real number, there exists another real number y such that y is equal to x squared. That's true. I can pick any number, let's say 3, then there exists a number y such that 3 squared equals that number. So it happens that y needs to be equal to 9. It exists. I can find a y that satisfies what I was hoping for. If I write the quantifiers in the other order, it means something completely different. Here, it means that there exists a number y such that for all x's in R, y equals x squared. And that is really false. If we think of a number, I'm going to pretend y exists, but of course it doesn't. I'm going to say y equals 9. Then for all x's, any x I choose, x squared equals 9. That makes no sense. There's one special case, or two special cases. If x equals 3 or negative 3, then miraculously 3 squared equals 9, but definitely not all numbers will have the property that x squared equals 9. So this is false, and we see that we need to be careful about the order. So that's what we did today. We saw the two quantifiers and how we can use them in logic. Thank you.